and the theory of control of dynamic systems such as large space structures. Fluid mechanics deals with the motion of fluids subjected to differences in pressure and temperature. Students learn about the flow of water around ship hulls, air around an aircraft, and blood in living tissues. The behavior of engineering materials subjected to a variety of environmental loadings is another important area. It involves traditional materials such as metals and alloys, as well as advanced materials like ceramics or fiber-reinforced polymer composites. Solid mechanics provides a fundamental knowledge of the response of solid materials applied to engineering structures. This is important to the design engineer concerned with safe and economical designs of a railroad rail or wheel, a single beam as well as the entire structure, or a plate in a ship or submarine. Students in the ESM program examine the fundamentals associated with this mechanical behavior and not simply how to apply handbook formulas. Projects in the 21st century will demand better educated engineers to support new energy sources such as fusion reactors, advanced transportation vehicles, and improved structural design of bridges and buildings. The increased utilization of space will lead to challenges far beyond those already met and answered by today's engineers. Areas of interest include repositioning of satellites, new designs for lightweight smart structures which detect damage and then repair or correct themselves, mining and manufacture in space, and advanced materials to meet the harsh environment of outer space. Advances in medical technology will be influenced by teams of medical doctors and biomedical engineers working together to develop new prostheses with direct nervous system control, totally implantable artificial organs which can completely replace natural organs, new blood-compatible materials which prevent clotting problems, non-invasive imaging, and new environmental designs which will enable humans to endure high G-loads. The National Aerospace Plane is an example of the challenges that will be faced by the engineers of tomorrow. This plane will be capable of runway takeoff, flying to low space orbit, and landing safely back on Earth. For its flight through the atmosphere, the outer shape of the aircraft design will be met by engineers skilled in fluid flow mechanics. Also, engineers with expertise in spaceflight must design the plane for the portion of its flight through outer space. Engineers educated in solid mechanics must design the structure for strength and stability. Structural materials will be developed and tested to assure their correct response under various environments. Stability, control, and structural vibration problems will be met by engineers educated in dynamics, vibrations, and control theory. Computational methods in finite element analysis will be required to meet the needs of these new designs. This allows the engineer to predict internal stresses and strains so that the design can be tested in the computer before actual construction begins. These engineers will be leading and managing teams of other engineers who are responsible for meeting such challenges. They should have knowledge in all of these areas so that proper cooperation can occur between teams of individuals working on these problems. The undergraduate finds a variety of employment opportunities available upon graduation. ESM graduates have been employed as research and development engineers in industrial and government laboratories, as structural engineers in the application of composite materials in aerospace and transportation vehicles, as process engineers in chemical industries, as automotive engineers by automobile manufacturers, as clinical engineers in hospitals, and as consulting engineers by professional engineering companies. Activities performed daily by previous graduates cover a wide variety of duties and responsibilities. The fundamental concepts of mechanics do not change and will continue to be the backbone of engineering, providing the basics for other engineering disciplines. All new discoveries and developments in engineering will build upon the engineering sciences. The ESM curriculum at Virginia Tech provides students with the knowledge they need as they enter into the world of the 21st century. Prepare yourself to be part of this exciting challenge.